Okay, folks, so we wrap up with talking about our last two differentiation formulas. We're going to talk about these four just because we've already talked about them. If you have two functions that are added together in the derivative, you can just separate them, f prime of x plus g prime of x. And what that means is, suppose you have, f of x is equal to x squared minus 3x. You could take the derivative of x squared, which is 2x, and then the derivative of negative 3x, which is minus 3. So it works to just take the derivative of each part. And same with subtraction, f prime of x minus g prime of x. But when you multiply them, it doesn't work out that way. So for example, you can't, suppose you have f of x is equal to the square root of x times x squared minus 2. You can't say, well, the derivative of the square root of x is 1 over 2 roots of x, and the derivative of x squared minus 2 is 2x. And so that does not work. It doesn't work like that at all. Here's how you do it. You take the derivative of f, and you multiply it by g left alone. Then you add the derivative of g times f left alone. If you are dividing two functions, you do the derivative of f times g, and then it's minus the derivative of g times f. But then it's all divided by g squared, so the original function squared. If you want to see the proof for those, I can show you. They're really cool, but I don't know if you'll reach out and ask that. So let's get an idea for exactly what that looks like. And so if you flip it over to, we're going to buzz on over here, it says differentiate the following functions. And so you can tell that for letter A, you can tell that this function has two things that are being divided. So you can't just take the derivative of the top, which is 2x, and the derivative of the bottom, which is 1, and get 2x. That's not the derivative. That's not how it goes. What we do is we look at the top, and we look at the bottom. We'll call the top f and the bottom g. And when you're using differentiation that way, we say that's f prime times g minus g prime times f, all divided by g squared. And so f prime is 2x times g, which is x minus 1. And that's minus. Then we take the derivative of the bottom, which is 1, times the top, x squared. All divided by x minus 1, the bottom, squared. So that's our new derivative. Now, we can simplify by combining some like terms. So if you look at on top, f prime of x is equal to, if we distribute this 2x through, we get a 2x squared. We get a minus 2x. We get a minus x squared, all over x minus 1 quantity squared. So f prime of x is equal to 2x squared minus x squared is just x squared, minus 2x over x minus 1 quantity squared. And that's my derivative. Okay? Derivative of the top times the bottom left alone minus derivative of the bottom times the top left alone divided by the bottom squared. So in letter B, here we have the product rule because you're multiplying those two things together. So again, you can't take the derivative of the first part to say 4x and the derivative of the second part to say, let's see, 10x minus 2 and say that that's my derivative. It does not work out like that. But I'm going to show you, very, very, very important here, that I'm going to show you what you do for the first two problems of your assignment. It says to find the derivative two ways. Number one, using the product or quotient rule, and then number two, by simplifying first and then using the power rule. So I'll do the first way, which is by using the product rule. So f prime of x is, when we use the product rule, we say f prime times g plus g prime times f. And the derivative of the first part is 4x times 5x squared minus 2 plus the derivative of the second part, which is 10x minus 2 times the first derivative, which is, or the first part, which is 2x squared minus 6. Now, if we multiply through, you can see that we get a 20x cubed minus 4x. Oh, I'm sorry, that's supposed to be an x there. X squared plus, now I have to FOIL this out. Looks like I have another 20x cubed, a minus 4x squared, a minus 60x, and a plus 12. That is 40x cubed minus 8x squared minus 60x plus 12. So that's my derivative. Now the second way of taking the derivative is to first multiply everything out. So f of x is, if we multiply this out, we get 10x to the fourth, get a minus 4x cubed. We get a minus 30x squared, and we get a plus 12x. Oh, looks like I made a mistake. Yeah, we'll get back to that. Okay, so we go ahead, we take the derivative, and we get 40x cubed minus 12x squared minus 60x plus 12. And that's our derivative. Does it match what we have here? It doesn't. I made a mistake somewhere. And it looks like when I took the 4x times the negative 2x, there should have been negative 8. And negative 8, negative 4 makes that negative 12. So a good way to check your answer by doing it both ways. I'm not going to go back and remake the video just for that one piece. But it looks like I multiplied too quickly. But two ways of finding the derivative. Now, some people are like, well, why don't you just use number 2 all the time? That's because at some point we'll say f of x is equal to the root of x times sine of x. Well, so use the product rule there, but there's no way you can FOIL it out like you would there, so you need to know the product rule. Difference is I haven't taught you the derivative of sine of x yet, or the derivative of natural log of x, or of e to the x. Those are ones you don't know. So let's practice again. Let's look at letter D. And right now we're not going to focus so much on simplifying. If you have basic combining of like terms, then you should. We're going to leave this one in expanded form because we're going to build off of it later. We'll call this F, and we're going to call this G. Now the derivative of the square root of x plus 3, remember that that is x to the 1/2 plus 3. And the derivative of x to the 1/2 is 1 over 2 x to the negative 1/2. Derivative of 3 is 0. So for our first part, f prime of x, we will get 1 over 2 roots of x. That's what this guy is right there. That's something you've got to get into your brain. 1 over 2 roots of x is the derivative of the square root of x. That should become kind of memory after a while. Times x cubed minus 2x plus 1. Plus, then we have the square root of x plus 3 times the derivative of g, which is 3x squared minus 2x. All right, it was 3x minus 2. Excuse me. And that's the derivative. We're not going to simplify this. We're just going to leave it like it is. Can you simplify it? Sure, you could probably find a way to combine some like terms, but it wouldn't work out very well. I'll be clear on the test when I want you to simplify. Letter E. We've got a complex fraction here. First, I'd like to simplify this complex fraction a little bit. So I have 2x minus 5 over 1 over 2 over x minus x over 1. So if I multiply top and bottom by x, I get 2x minus 5 over 1 divided by 2 minus x squared over x. Multiplied by the reciprocal, and we get 2x squared minus 5x over 2 minus x squared. So to be clear, all I've done at this point is just rewrite it. So this is f of x. So now I'd like to find the derivative. I take the derivative of the top, 4x minus 5. I leave the bottom alone, 2 minus x squared, minus the derivative of the bottom is negative 2x. So therefore it will be a plus 2x times the top, 2x squared minus 5x. All over the bottom squared. Let's combine some terms because they are going to combine very easily in the top. First we have to multiply everything out. I get a negative 4x cubed, a plus 5x squared, a plus 8x, minus 10, plus 4x cubed, minus 10x, all over 2 minus x squared squared. Notice the x cubes go away. And we're left with 5x squared, 8x, and negative 10x make negative 2x minus 10 over 2 minus x squared squared. That's my derivative. You look at an example like f and you're thinking that that's super difficult. Really not that bad. Watch how I write this out. The derivative is equal to the derivative of the top. What's the top? The top is negative 3. The derivative of that is 0 because it's a constant. Times 3x to the fourth plus 2x squared minus x. Minus the top, which is negative 3, so plus 3, times the derivative of the bottom. 12x cubed plus 4x minus 1. So that all goes away. It's all over 3x to the fourth plus 2x squared minus x squared. And so we have 36x cubed plus 12x minus 3 all over 3x to the fourth plus 2x squared minus x quantity squared. That is the derivative. If you're given a table of values, here it talks about f minus g prime of 3. So you do f prime of 3 minus g prime of 3. Well, f prime of 3, by looking at the table, is going to be negative 2. Minus g prime of 3 is going to be negative 1. And so we get negative 1. F plus g prime of 4. I will do f prime of 4 plus g prime of 4. Well, f prime of 4 is 1, and g prime of 4 is 2. I get 3. But when we are multiplying, we must do f prime of 5 times g of 5 plus g prime of 5 times f of 5. So you use the product rule. F prime of 5 is 3. G of 5 is 0. G prime of 5 is 1. f of 5 is 6. 0 plus 6 is 6. Instead of writing it all out for this next one, I'll talk it through. We're doing division. So I do f prime, which is 1, times g left alone. G left alone is 8. Minus g prime, which is 0, times f left alone, 3. All divided by g squared. That'll be 8 squared. So we get 8 over 64, which is 1/8, and that is your derivative. Okay. This is muy importante, okay? Gotta really focus on these. Good old friend, write an equation for a line tangent to a curve at a given point. In order to write an equation for a line tangent, I need slope and I need a point on the line. These are challenging problems for a lot of people, so I encourage you to take your time and lean in and really focus. We know that it's tangent at the point x is equal to 0. I need a y value. In order to produce the y value, I will plug 0 in. And when I do, I get 4 times 0, which is 0. And I get 0 minus 0 plus 2, which is 2. So 0, 0 is our point. It goes through the origin. How do we find slope? Slope occurs at the derivative. The derivative tells us the slope. So we need to focus on finding f prime of x, the derivative of this, and that will generate for us the slope. I take the derivative of the top, which is 4, leave the bottom alone. The top times the derivative of the bottom. All divided by the bottom squared. Now, here's what people do, and it drives me insane. People actually multiply this all out, and they try to simplify it when that's not what the question is asking. The question is not asking for a simplified version of f prime of x. The question is asking for the slope, so you can write the equation for the line. Just go ahead and plug in 0 right now. Plug in 0 for all these pieces. And notice what happens when you plug in 0. Like here, those go away. You get 4 times 2 is 8. Minus, this is all gone. That's 0. Divided by, here you get 2 squared on the bottom, which is 4. So our slope is 2. So that's all we need to do is just plug in 0 so we can determine the slope. Now I have y is equal to 2x, and that's the equation for the line tangent. Go ahead and graph them on your calculator if you want to see that they are a tangent, but that's a great way to check your answer. Like, look at this next one. Again, our point is going to be at x equals 0. If you plug in 0, you get 0, 0, 0, you get 3, and then here you get 1. So 3 times 1 is 3. So it goes through 0, 3. Super easy because I picked 0. Notice how nice I was. Yay, Mr. Gentz. All right. But we need to be able to determine the derivative in order to find the slope. Well, don't multiply it all out, folks. Just go ahead and use the product rule. The product rule says the derivative of the first part, which is 4x cubed plus 15x squared minus 6 times x squared minus x plus 1 plus, now we have the derivative of that, which is 2x minus 1 times this whole x to the 4th plus 5x cubed minus 6x plus 3. In order to determine the slope, you plug in 0 because it says it's happening at x is equal to 0. Well, notice those go away. And I get negative 6 times 1 plus negative 1 times 3. Negative 6 times 1 is negative 6, and negative 1 times 3 is negative 3. Get a negative 9er out of that. So y is equal to negative 9x plus 3. So I made what looked like a very complicated problem into a simple problem. Okay, understand what you're looking for. Don't bother simplifying everything if it's simply asking for the equation for a line tangent. And we conclude. Let's look at a graphical representation. It says f plus g prime of 3. I will find f prime of 3 and add it to g prime of 3. As you look at the graph, we're going to look at 3. 1, 2, 3. This is where the graph is at. And what is the slope of the graph at that spot? It looks like the slope of the graph, if we can see, we go up 1, 2, 3, 4, 5, 6, 7, 8. And we run 1, 2, 3, 4. It looks like the slope at that spot is 8 over 4, or 2. Now let's look at g prime of 3. At 3, g has a slope of down 1 over 1, negative 1. And so the answer is 1. Here we will do g of g prime of 3 minus f prime of 3. Well, g prime of 3 you already determined was negative 1. And f prime of 3 we determined was 2. Look what happens when we get the product rule. We do g prime of 3 times f of 3 plus f prime of 3 times g of 3. We've already determined that g prime of 3 is negative 1. We've already determined that f prime of 3 is 2. Now what I need is f of 3. What is the function's value at 3? Well, f of 3, it looks like, is 0. And g of 3, it appears to be, is 4. Negative 1 times 0 is 0, and 2 times 4 is 8. Finally, we have the quotient rule. We'll do f prime of 3 times g of 3 minus g prime of 3 times f of 3 all over g of 3 squared. F prime of 3 we've determined to be 2. G of 3 we've determined to be 4. G prime of 3 we've determined to be negative 1. And f of 3 we've determined to be 0. G of 3 we've determined to be 4. And so we have 2 times 4 is 8, and 4 squared is 16. We get 1/2. There you have it, folks. That's the introduction to the quotient rule and the product rule. A longer video. I apologize. You have a lot of time to get ready for your test. I hope that this will be an excellent test. You're doing great work, and I enjoy seeing you in class. Reach out if you need help.